Okay, we're starting a chapter concerned with matrices. Matrices are a way to organize things, and you might not think about it. Anybody in here interested in going into computer programming? Well, when you design programming, a lot of things are set up on matrices. You know, you go to Walmart, you buy something. When you buy your pack of gum, it goes into a matrix and it gets subtracted off. That way inventory is already taken care of. When they scan your barcode, that's what happens. But it goes into a matrix. And we're going to learn how to add, subtract, multiply matrices. We're going to work with solving systems of equations, other methods than addition, elimination, or substitution that you saw earlier. We're going to see it with matrix algebra. So first off, we're just starting with the basics of it. So in order to identify a matrix, you identify it by its dimensions. And dimensions are always row by columns. So for 10 through 15, what would this matrix be called? And notice the matrices has the little brackets on it. This would be how many rows?
2.
And how many columns?
3.
So this would be classified as a 2 by 3 matrix. What about my next one?
1 by 4.
So it's first you state how many rows, right? So how many rows are there?
4.
4. And then how many columns?
By 1.
There's only one column, so it's classified as a 4 by 1. What if I just had this?
1 by 1.
It'd be a 1 by 1. And we need to know the dimensions. The reason why we need to know the dimensions, when we start adding and subtracting, you're going to find that in order to add or subtract matrices, they have to be exactly the same dimensions in order to add or subtract. Now, multiplication works a little differently, so we'll see that later as well. What about that one?
2 by 4.
2 by 4? Everybody agree with 2 by 4? Okay, is that enough of what you're doing on 10 through 15? Okay, we're going to move on then to the 16 through 23. On 16 through 23, you're going to see only equivalent matrices. So equivalent matrices means I have to have another one the same dimensions in order to be classified as equivalent. So if I have a 2 by 3, the other one has to be a 2 by 3. If I have a 1 by 1, it has to be a 1 by 1. So all matrices have to be equivalent. They have to have the same number of rows and the same number of columns. So this finishes it out. What was it? 16 through 23?
Yeah.
Okay.
Is that 7?
That's a z squared. And I think the very first group, the first 3 or 4 problems are like this kind, which would be simple solve once we got going. But your objective in this group of problems 16 through 23 is to solve for the variables.
That's really simple.
And a lot of them are going to be simple. Then there's going to be some that we have to use addition, elimination, or substitution, one of the two. So we said each respective position equal to the position, the same position in the second matrix. So that would be row 1 first column to row 1 first column. Everybody follow me there? So that would be 5x equals 15. That would be 2 equals 2. That would be 3y equals a negative 6. That would be, excuse me?
Will we need to write the ones that do not have the extra?
No, you really don't. I'm writing them just for the sake that we have the position. So we have z squared equals to 25. We have 12 equal to 12. And we have 4x equal to 12. Now, once you've got each position assigned, like first row, first column to first row, first column, or second row, second column to second row, second column. Then you're ready to solve whatever. And Nicholas is right. The ones that don't have variables in, you don't even have to pay attention to, so we're getting rid of those. But now we go back, and this one's an x. What would I do to solve that for x? So x is going to be 3. This one's got a y. What would I do to solve that for y? So y is going to equal,
-2.
okay. And this one, z squared equals 25.
Square root
And when you square root,
equals 5.
equals positive or negative 5. And we got one over here. Divide by 4 and x equals
3.
And then we have variables. We write our answers in ordered pairs. Well, we write them in alphabetical order, right? Remember doing that when you solve systems? So this is x, y, and z. Notice my x is the same. If it wasn't the same, I'd be in trouble. Okay? If you're solving and you have multiple variables and you have more than one x, both x's should end up being the same. So that's kind of the way they put something in there to check it. So my final answer on this example would be 3, -2, and a positive or negative 5. Okay. This one I'm not going to make as lengthy, but I'm going to make you think about it. Okay, so what would we assign here? First row, first position would go to first row, first position. First row, second position. And third column.
-2.
Oh, thank you, where did I get the 3? Okay, so we have y is a -2. So that one's already done for us, isn't it? So this one's done. Can I go back here and solve this one? So x is going to equal,
3.
and what about in the middle? It says xy equals -6.
Plug in the
Yeah, if I didn't know one of them, I could substitute it in to find the other one, but what's this really telling me?
It's 2 times -2.
Does it work?
Yes.
Yes, so that means my answer is
3.
correct. So it's just another way of checking.
These are
You're going to like this chapter.
easy.
Now, like I said, you're going to have the majority, the very first part of the 16, 17, 18, they're going to be like this, where it's one position to one position. Now, what's different about this one? What's the dimension of this matrix?
It's 1.
It's 2 by 1. What's the dimension of this one?
2 by 1.
2 by 1, because these are married, so that's like one position alone. Does everybody follow what I'm saying? I always get somebody that wants to think there's a 2 by 2, but it's not. It's addition and subtraction that's joined together. So when I set first row, first column equal to the first row, first column in the second one, what am I going to have? 2x plus 4y equal, and the second one would be x minus 2y equal 0. Now, this is a system, so with the system, we've got to solve it by either using addition, elimination, or substitution, right? So I'm going to use both methods, and then you guys can use whichever method you prefer. So first, let's go over addition, elimination. In addition, elimination, don't you line your variables up, and you try, it's pretty much self-explanatory in the fact that you want to eliminate one of your variables. So to eliminate one of my variables, let's see, I can either eliminate x's or y's, but I need to get these to be the same value, don't I? So like, the y's would be, this one already has one positive, one negative, so I may want to work with the y's first. What would I need to multiply this by, the bottom one?
2.
in order to make it be able to cancel. So we're gonna multiply the bottom equation by 2. Now what will you get when you add those together, since it's called addition and elimination?
X.
Cancels equals 8, so x equals 2. Now we know what x is, what do we do to find y?
Substitute X.
Substitute it back in. So you're really using substitution again, so I'm going to put it into the second equation if that's okay. So 2 minus 2y equals 0. Subtract 2. And y equals 1. So my answer on this is 2, 1. And there's really no need to miss any of these because you can sit it back in and check. Is 2 times 2 plus 4 times 1 equal to 8?
Yes.
Okay, so we did that one by using addition elimination. Now, with substitution, I always put my equations besides each other. And then I choose one of them and solve it for either x or y. And it doesn't matter which one you choose, although there will be one equation that might be easier than the other. So probably I would want to choose this one, right? And what would I want to solve it for? X. So to solve for x, you would add 2y. So now into the other equation, wherever there's an x, I'm going to put 2y. So it's going to be 2 times 2y plus 4y equals 8. Now what would we do to solve it?
Just before Y.
Multiply. So 8y equals 8. So y equals 1. So now I know y is 1, so I can go back here and substitute 1 in place of y. So x equals 2. Did I get the same answer?
Yes.
And should we?
Yes.
Yes, so it doesn't matter which one you choose, you should end up with the same results, as long as you do all your math right. Okay? Another example, you don't need to write this one down, we're just going to do one more for good measure. Okay, so what are my dimensions?
1.
It's 2 rows and 1 column, so 2 by 1. So my first position would be x plus 5y equals, and the second one would be, now which method do you guys want to use? Just elimination?
Better.
You like elimination better?
Yeah.
Okay, so we need to line them up. And what do we need to do to either of them to get rid of one of them?
Multiply the top by -2.
You can multiply the top by a -2, or you can multiply the bottom one by 5. Either way would work.
Or
Okay.
maybe to 1/2 and 11.
You could do that too, but then you'd be working with fractions. I think I'll take the first method I heard. Multiply the top by -2. Is everybody agreeable there? So -2x minus 10y equals -16. Now what happens when you add those together?
Cancel -11y equals -11 divided by -11.
So y is 1. Now we want to substitute it. Which one do you want to substitute it into?
Bottom one.
This one? Or that one?
That one.
That one? So 2x minus 1 equals 5. So adding 1, we're going to get 6.
Get 3.
So your answer is 3, 1.
Mm-hmm.
And then we can check it. Let's put it in the other one. 3 plus 5 times 1, does it equal 8?
Yes.
Okay. You guys have questions? So again, the assignment's page 156, 10 through 23. The 10 through 15, all you're doing is stating the dimension. And then 16 through 23, you're going to do some solving of some kind to solve for the variables that are in the problem. Okay, I'd like to see everybody's first 16. If you get more, I'd like to see it.